Saxon Algebra 1, lesson 54. Mark this one in your calendars, gentlemen. This is one of those momentous days where we introduce a technique that we're going to be using and using and using and using and using and using and using. And I'm very excited to be here at the beginning of all things with you. Solving by substitution. All right. First, I'm going to tell you about a little something about what substitution is, and then I'll show you what we're going to solve. Here's the thing. If we have two expressions, A and B, and we say that they are, here's the fancy expression, equivalent, let me just add that there. If A and B are equivalent expressions, if they're equal, then A can be substituted, and I'll show you what this means later, for B, and B can be substituted for A. If they're equal, we can plug them into each other, right? We can replace them with each other because they're the same. So why couldn't we, right? This seems so obvious, but wait till you see how fun it is when we play it in our problems. All right, I'm gonna show you why this is helpful. Very often in algebra, in so many different circumstances, you guys, we're going to be given two equations. Let me give you an example. 2x minus y equals 1. Okay, there are two equations. Notice that each one has an x and a y term and a plain number term. That's important. We'll talk more about that as we go on, but just accept that that's the way we do it. There's an x term, a y term, and a plain number. Notice these guys are mixed up. They're not in the same shape. Right here we have the x and the y on one side, the number over there. Here the x is by itself, and the y and the plain number are over there. Don't let that bother you. When you see this shape, a parenthesis, around the front of those equations, that tells you something important. It tells you this is called a system of equations. That's the fancy name for it. And what that means is we want to find one value for x and y, one value for each of them, that makes both equations true. Okay? So we're looking for values that we can use for x and y that will make this equation true and that will make that equation true. Solving a system of equations is something that we're going to find very useful for lots of different problems. All right? We're going to learn many different ways to solve them, up to 5 different ways. This is the first one, and it's called substitution. So now let me go back to this one. I'm going to have to copy it over again. And I'm going to walk you through how we can use substitution to solve this. And we'll find a value for x and a value for y that makes both equations true. Let me flip. It's always sad when I get to the end of the page, right? All right, let me copy them over again. It was 2x minus y equals 1. All right, and then what's super important is this. Sometimes what John will do is he will put letters here just so that we can talk about the two equations. This is equation A and this is B. It's just to help us with the talking point. This is the very important symbol because this tells us that it is a system of equations, and that means we're looking for a value for x and y that will make both of them come true. All right? There's lots of x's and y's that could make just this one true. There's lots of x's and y's that could make this one true. But to find a value for x and a value for y that will make both come true, that's a bigger challenge. So this is what we're going to do. Now, notice, like I said before, equation A has an x and a y, an equal sign, and then a 1. Okay, this is a pretty normal way we see these. B is more important. B, well, it's not more important, but it's got a very important consideration. B has got a plain x all by itself, and it says x is equal to that. Now, we said that if things are equal, you can substitute them, right? There's an x in this original equation, and then this is another value for x. So what we can do, and P.S., we can't solve these as they are now because there's 2 letters in each one, so we can't solve them by themselves. Somehow we have to blend them together so they can share data, essentially, and we can make both of them true. What we're going to do is we're going to take this chunk of information that is equal to x, and we're going to plug it into this equation A. We're going to substitute it and then solve from there. And let me write it this way. I'm going to take equation A, and I'm going to write it, only instead of putting the x in, I'm going to put parentheses in. Right? That's equation A. 2x plus y equals 1. I'll put the little x up there. I don't want to write a plain x because I want to substitute this expression in, right? We say this is equal to x. So I can write this chunk right in here where we said the x goes. Does that make sense? I'm substituting it in. Now, notice what happens. The x's are all gone. This is just up here to remind me of what fits in this block. But when I substituted this value in, I created a combined equation, because this is the B part, right? I'm going to just do that. This part is the B. This is the A. I basically melded the 2 equations together, and now if I solve it, I'm going to be well on my way to my overall challenge of finding a value for x and y. What I have to do to solve this is I have to distribute. I'll get minus 6y plus 22 plus y equals 1. All I did was distribute this first part. Now, let's see. Let's combine these like terms. Minus 6 plus y is, second, let me check my signs. Oh, yeah, this is a minus right there. So this should be a minus, and this should be a minus. Okay, so I just copied it wrong here, and it just copied through. It didn't affect our distribution at all. All right, so minus 6y minus y, that becomes minus 7y plus 22 equals 1. And then I'm going to swim the 22 over this way, right? So now I have minus 7y equals, let's see, that'll be minus 21. I'm almost there. This is just basic solving that you know how to do. I divide by minus 7. And what I get is that y equals, that all reduces, the 2 minuses become a plus. 21 divided by 7 is 3. We get for our answer that y is equal to 3. So 3 is the value for y that will make both of these equations come true. So we're halfway there. But we have to also find out what the x value is. So we're going to take this value and we're going to go back to our original equations, which are messy because I copied it wrong. But we're going to plug this into one or the other of them. It doesn't matter which. They both will work. And we're going to come up with a value for x. Now, we could plug it into this first one and do some algebra, and we could get the answer really easily. That would be fine. But this b is all set up because, look, if we plug the 3 in here, substituting again, then we just simplify this side, and that will give us our x value. So b is set up to be a little bit easier to work with. So I'm going to take x equals minus 3 times y, except I know that y is 3, so I'm going to put the 3 in there, plus 11. Do the algebra on this. This becomes minus 9 plus 11, and x equals 2. I'll just write that in so it's clear. Make sense? I just multiplied. So our final answer is that x equals 2 and y equals 3. And here's the part that may seem a little weird right now, but I'll talk about later about why. I've given you enough new things to think about today. You know how when we write a pair of points to graph them, we write them as x, y? We're going to do the same thing with our answers here. We're going to write them as an ordered pair. So x is 2 and y is 3. So the best way to write our answer is like that. This is also good, but this is the best answer, and I'm going to tell you why. I want to tell you why so that I can blow your minds a little bit. These, if you noticed, are graphable lines. We could graph these on a Cartesian coordinate system. They're both lines that could be graphed. If we graph them accurately, the point at which they would cross is this point, 2, 3. So I'm not gonna graph them now, but let's just pretend, right? 1, 2, 1, 2, 3. This is the place where they would intersect. So let's just pretend I'm just drawing any random line. But it would be something like that, where they would cross over at this point that we determined. Okay, so we found the solution to a system of equations, and it represents, by substitution, and it represents the place where the two lines intersect when graphed. How fabulous. Let's do another one. $54.2. There are 5 of these in all. All right, we're just going to buzz through them. That might seem like overkill. Oh, this is 2, not 3. Right? Yes. But I want to make sure you guys get the hang of this. Here comes another one. 2x plus 3y. All right, there's our new system of equations. We see this one is in the standard format, x, y, plain number. This one is set up with y all by itself. So this one is ripe for us to substitute the y values, right? Last time it was set up x equals. This time it's all set up with y equals. So let's substitute the y's instead. So again, that would be y's, right? Sorry. Okay, so we start with the equation that we're going to plug into, and we write that out, 2x plus 3, and then we put a big space where we're going to substitute it in, equals minus 13. So this is the A, and then the B is going to go in here, right? This is just to show you where it's going to belong. Y is equal to x minus 6, so x minus 6 goes right there. Cool, right? We're substituting. So now we've combined A and B. We've kind of poured them together. That is a very good sign. Let's distribute. 2x plus 3x minus 18 equals minus 13. We will combine like terms, and we will add 18 in one step. Because honestly, we have other things to do with our life. 5x equals 5. Oh, John. X equals 1, right? I love it. Now, again, we take this, we plug it back into one of the original equations, and we choose whichever one we like that we think is going to be easier. I think B is going to be easier. So we will do y equals, x is 1, 1 minus 6 equals negative 5. So we get y equals negative 5. Huh. Okay, and then we write that as a point because we know that if we graph these lines, this is the place where they would intersect 1, negative 5. That's the right answer. Remember to always write your x first and your y later, right? Don't mess that up. Okay, cool. Another one. So we learned you can substitute an x or a y, right? 3x plus 2y equals 3. I'm not sure why John has so many examples in this section. Okay? We see it. This one's the basic. Here's the x by itself. We'll substitute that in right there. We'll write this equation out with a hole there, and then we'll put that in its space. 3 plus 2y equals 3, and then that goes in there. 3y minus 10. It always is going to work out that the x's, the letter that you're substituting, that letter will disappear and you'll be left with the other letter. We distribute 9y minus 30 plus 2y equals 3. We'll combine our like terms at the same time we add the 30. We get 11y equals 33. John, he's a buddy and a pal on these, you guys. He comes up with the cutest little scenarios for us. And once again, let's plug it into the first one, just so I can show you that it works. 3x plus 2y, and y is equal to 3, equals 3. Yeah? 2 times 3 is 6, so I'm going to subtract 6 from both sides. 3x equals minus 3. X equals minus 1. All right. And we can see it would have been the same thing here, right? Because it would be 9 minus 10 would be minus 1. All right. And so our answer, that's the x, that's the y. We want to write it in point form, minus 1, 3. That's the place where these two equations represent lines. If we graph them, this is the point where they would intersect. Okay. 54:4. Use substitution to solve for x and y. John is still being really kind to us. He's setting the second equation up all ready for substitution. Later, he's going to make us do a little bit of work to get this organized the way we want. But right now, he's still being very sweet. Y equals, that's the part we'll substitute, and there's where we'll put it, right? That will go in there. All right, so we take the equation that we're starting with and we leave a hole where we want to substitute. Minus x minus 2, and there's the y where we'll put the other one in, equals 4. I always write the first one first before I plug the second one in because it's easy to get confused once you start jumping back and forth between the equations. So I like to write the first one out perfectly, leaving a blank where I'm going to substitute in. Then I go back and do the substitution. All right, it just helps minimize mistakes. All right, now we have to distribute the minus 2, so we better be careful with that. Minus x plus 6x minus 16 equals 4. These two will go together, and we'll add 16 to both sides. 5x equals 20. See, John just makes this smooth as silk, doesn't he? X equals 4. And now we will plug back in. As I showed you last time, you can plug it into either one. It will work out. You might as well just choose whatever looks easier. I like this one. Y equals minus 3 times 4, because x is 4, plus 8. Minus 3 times 4 is minus 12, plus 8. Y equals minus 4. I'm going to write that over there. And then our ordered pair is 4 minus 4. Remember, it's always x and y. This is our answer. If you're doing a problem like this on a test, I highly recommend you write this and then I want to see that. If you just showed me this, I might give you full points, but especially as, no, I want to see this. I'm taking that back. All right, that's the right answer. Yay. And one more. 54.5. Use substitution to solve for x and y. 2x plus 3y equals 5. And, oh, look at this one. This one looks really weird, right? Okay, don't let it trip you out. We see, okay, we can substitute the x's just like always. I'm going to write the first equation with a gap in it. Now we look, what do we substitute into it? That. Oh, okay. Right? And it becomes 5y equals 5. Y equals 1. Well, that looked weird, but it turned out to be really, really simple. And we can see that x equals y, so when we plug that in, we can see, well, x equals 1 as well. And so our ordered pair is 1, 1. Well, I like ending on a positive note. That, you guys, is called solving a system of equations by substitution. Feel smart. You are hardcore algebraian people at this point. Your mathematics just took a giant leap forward, and we're going to be doing this in all kinds of different scenarios for years to come. I hope you're excited. All right, that's the end of lesson 54. Thanks, guys. Bye.